Hi, my name is Priya Dhawka, and today I will be presenting our paper entitled Better Little People Pictures, Generative Creation of Demographically Diverse Anthropographics, on behalf of my colleagues, Perera and Dr. Wesley Willett. This work was done at the Interactions Lab at the University of Calgary. Throughout the COVID-19 pandemic, news outlets in the US emphasized the death toll of victims using anthropographics. Anthropographics are visualizations with human-shaped symbols and use simple, sometimes generic human shapes to show data about people. By showing death and infection counts using human shapes, news outlets tried to humanize victims of the pandemic and evoke a sense of togetherness amongst their audience. However, these visualizations, including both contemporary anthropographics and classic techniques like isotypes, tend to rely on demographically homogeneous representations that fail to show the differences between individuals and distinct demographic groups. In response, we proposed demographically diverse anthropographics that represent demographic diversity using physical characteristics as alternatives to demographically homogeneous representations. In this work, we contributed ways to create diverse anthropographics that reveal more humanizing detail about the people behind the data and their demographics. However, several challenges still exist when creating these kinds of diverse visualizations. For starters, designing diverse anthropographics of large demographic datasets is time-consuming. Designers also have distinct and highly personalized processes. For instance, Mona Chalabi, a British journalist and illustrator at The Guardian, whose work is shown on screen, creates the famous data stories using a variety of tools, including hand-drawing several of her illustrations, which she then later combines using tools such as R and Adobe Illustrator. Visualization designers also often require access to specialized design resources, which vary greatly between freelancers and designers at large organizations. Additionally, as we documented in previous work, there is a lack of available data about demographics and the physical diversity of the populations being represented. At the same time, there has been growing interest within the visualization community to consider the potential of generative AI to support the design of visualizations. For instance, Schrödinger and colleagues point out that the design of anthropographics specifically could benefit from the efficiency of generative AI systems. However, biases on the part of designers creating diverse anthropographics, as well as documented biases in current text-to-image generators, make these systems challenging to work with. For instance, Bloomberg Media conducted a deep investigation of the biases in Stable Diffusion and found that the model perpetuates harmful stereotypes about marginalized groups, hence highlighting the need to have a human in the loop to critically inspect the output from these systems. And so, in this follow-up work, we ask, how can human designers leverage text-to-image generators for the rapid creation of diverse anthropographic assets, while critically considering potential sources of risk and bias in these systems? Our paper contributes a conceptual workflow for creating diverse anthropographic assets for visualizations, with which we then explored a variety of new anthropographic designs. We also contribute a set of technical and social challenges involved in the use of text-to-image generator systems for anthropographic design, as well as a number of AI-enabled research opportunities in this area. I will briefly go over each contribution in this presentation. In terms of our methods, we took a reflective and design-oriented approach to explore a variety of text-to-image generator systems for a period of 6 months. We spent the first 3 months conducting an iterative and open-ended set of experiments using Artbreeder and Stable Diffusion, before settling on experimenting solely with Stable Diffusion. We then spent the next 3 months developing and testing custom prompts using demographic category labels, and by varying descriptors for human features, such as hair, facial features, and clothing. We designed a number of new visualizations with these generated anthropographic assets, which we further showcase in our paper, so please check that out for more details. We also experimented with tailored variants of Stable Diffusion to produce assets in various visual styles, including models and prompts for abstracted and artistic styles, as well as cartoonized and more photorealistic styles. From these experiments, we then developed our conceptual workflow, which consists of two stages: a data curation and model selection stage, and an image generation and refinement stage. Due to the potential of designer and model bias in the creation of diverse anthropographics, our human-in-the-loop approach attempts to systematize the design process in a way that allows designers to understand the implications of key decisions that might result in inaccurate or biased representations. I will be going into more detail about the workflow later in the presentation. We also provide an instantiation of our conceptual workflow in Google Colab notebooks, which are included in our supplementary material. Now, to illustrate our workflow in action, I will discuss one of the case studies that we describe in the paper alongside the workflow stages. This specific case study involves the creation of photorealistic anthropographic assets and visualizes data about the Electoral College in the US for two states, Wyoming and Florida. To create assets for this infographic, we used the realistic vision variant of Stable Diffusion, which is fine-tuned for photorealistic images. In the data curation and model selection stage of the workflow, we used demographic data for residents of the two states, drawn from PUMS, the United States Census Public Use Microdata Sample. We randomly sampled data for 20 individuals from Wyoming and 75 from Florida. We then chose a generative model based on the visual style of the final visualization. Here we are using a variant of Stable Diffusion to create photorealistic assets. We then used age, gender, race, and ancestry data to generate anthropographic assets. During the image generation and refinement stage of the workflow, we conducted multiple iterations to develop a reliable prompt template. We then batch generated the set of 95 images, manually inspecting and repeating image generation for images with visible aesthetic issues, such as cropped faces or malformed accessories, or images which raised bias concerns for us, such as clothing that might reflect unrepresentative stereotypes. We encountered several challenges when experimenting with text-to-image generators to create diverse anthropographics, and I will be highlighting two main ones that we think are most pressing here. One of the biggest challenges of using text-to-image generators for designing diverse anthropographics are the ethical concerns and biases in these systems. Text-to-image generators are opaque and flawed systems, and a growing amount of research is pointing out the flaws in these systems that produce hallucinations and unrealistic or problematic imagery. There are also deep-rooted concerns about data agency and privacy, concerns around the commercialization of public data for profit, labor issues around data annotation in the Global South, and serious concerns around respecting artistic integrity. As the list of ethical concerns keeps growing, we advocate for designers to be more critical in their usage of these systems and to weigh potential benefits against adverse impacts. The second challenge focuses on the output of text-to-image generators. As we show in our case studies, it is challenging to create images of people with sufficient variation between them. Not all people with similar demographics look the same. However, with the way in which current text-to-image generators are trained, using additional modifiers in the prompt template does not result in sufficiently distinct output images of people. While online communities have experimented with various approaches to create diverse images of people, this remains an open problem. And lastly, I want to highlight open research opportunities in this area around AI-supported anthropographic creation. And for the sake of time, I will be focusing on interactive anthropographic design tools. Generative AI can support the design of interactive tools at various steps of the visualization process. For instance, to better support audience interpretation of these visualizations, tools to explain the provenance of anthropographic assets will be especially useful for visualizations with photorealistic images, and tools for auditing outputs and assessing credibility can be useful for identifying biases and inconsistencies in the process. To conclude, our paper contributes a conceptual workflow for creating diverse anthropographic assets for visualizations using text-to-image generators. Generative AI systems can support the rapid creation of diverse anthropographics, but require significant communal research efforts to mitigate the risks and biases in these systems and their adverse impacts. Please check out our paper for more, and thank you for listening.